Hi guys, this time I want to discuss about a problem that I designed for my artificial intelligence class. This is a non-deterministic problem which will involve probability and chance. We will use Expectimax to solve this problem. Okay, let's start with the problem. So you are facing a dice game, or we should call it a die game because we only use one die, and then you have 5 rounds. Your action will be to stay or to quit. If you choose to quit, you will get 1000 rupiah and then the game ends. If you choose to stay, you only got 400 rupiahs and then you have to roll a die. If the die show a number that is equal or smaller than your current round, then the game ends. If not, continue to the next round. So, for example, if in the first round you choose to stay, you roll a die, and then you got number 1, and then you have to end the game and only got 400 rupiahs. Another example, if you choose to stay on the first round, and then you got die number 6, and then you continue to round 2, and then you decide to quit. So you will get 1400 rupiah as your reward. In the final round, or on the 5th round, if you choose to stay and you got die number 6, you will get an extra bonus for 1000 rupiah. So the problem is, in which round will you decide to quit, or will you stay until the final round? If you want to think about this problem more, or you want to solve it yourself, please pause the video because the next I will going to explain about how I solve this problem using Expectimax. I will utilize maximizing node and chance node. So for the first round, you have 2 options, to stay or to quit. If you quit, you instantly get 1000 rupiah and then the game ends. But if you choose to stay, you will have a chance or probability that you will survive, or you will end the game with only 400 rupiahs. So if you choose to stay, the probability that you will end the game or continue to the next round is like this: 1/6. That means only one number that will get you to end the game on the first round, and then the other 5 number will get you to the second round. And then on the second round, you will also have 2 options, which is to quit or to stay. If you quit on the second round, you will get 1400 rupiah. And then if you stay on the second round, you will roll another die. So the probability of you survive of this die roll on the second round is slimmer than the first one. So if you got the number 1 and number 2, you will end the game and you got 800 rupiah from the first one, 400, and then the second stay, 400. You will go home with 800 rupiah. The other 4/6 probability, you will go to the round 3. In round 3, again, you will have 2 options, which is to quit or to stay to roll the next die. Again, in round 3, you will have 2 options, which is to quit or to stay. If you quit, you will get 1800 rupiah, which is from 400 stay, and 1000 quit. So if you quit on the third round, you will get 1800 rupiah. So if you choose to stay, you will roll another die, and then you will meet another probability, which is a half for getting 1200 rupiah, or the other half, you will go to round 4. In the round 4, you will get a similar option. You can quit or you can stay. If you quit, you will get 2,200 rupiah from 1, 2, 3 stay and 1 quit. So 1 quit is equal to 1,000 and 3 stay will equal to 1,200. So if you stay, you will meet another chance with a slimmer chance to survive. This time you will get 4/6 probability you will end the game, and only 2/6 that you will survive to go to round 5. In the round 5, again, similar action. You will have two options, quit or to stay. If you quit in the fifth round, you will get 2,600 rupiah. And then if you choose to stay, you will roll another die, and then this time the chance is even slimmer. You will only have 1/6 probability that you will survive, and then you will get the bonus, extra bonus, which is another 1,000, or you will end the game with 2,000 rupiah from 5 stake. Okay, now let's count the expected utility for each node so we can decide which one is the better policy to take in each round. In Expectimax, there are two types of nodes, which is the maximizing node, the orange triangle, and the circle or the chance node. So to calculate the chance node expected utility or the expected value of this node, we can use the weighted sum. So the weight is the probability, and this we multiply the weight and the expected utility value. So for the first chance node, the last chance node in here, the expected utility is 5/6 times 2,000 plus 1/6 times 3,000. So we get the expected utility of this node is 2,167. And then for this node, this is a maximizing node. So we will choose the max value between these two options. So if we choose stay, we will get the expected utility of 2,167. And then if we choose to quit, we will get the expected utility of 2,600. So in this node, we will choose to quit with the expected utility of 2,600. So doing the same procedure, we will calculate this chance node, which is the expected utility of 4/6 to get the dice under the round. So 4/6 times 1,600 plus 2/6 times 2,600, and then we will get 1,934. And doing the same procedure such as before, we will choose the max value between quitting and staying in the round. So in this round 4, we will choose to quit, and then we will get the expected utility value of 2,200. So for the round 3, we meet the chance node again, and then we calculate by the same procedure, which is sum of product, a half times 1,200 plus a half times 2,200, we get 1,700 in here. So in this third round, it's still better to quit rather than staying in for the next round. This chance node, doing the same thing, expected utility times the probability, expected utility times the probability, and then we get 1,467. So the expected utility of quitting in the round 2 is smaller than expected utility of staying in the round. So on the round 2, it is better for us to have a policy of staying in the game. For the first round, we meet a chance node again, and then the expected utility for this node is 1 over 6 times 400 plus 4 over 6, plus 5 over 6 times 1467. So we will get expected utility of 1290 for this node. And then we conclude for the first round, we will pick to stay to get the expected utility of 1290. So by examining this tree, this Expectimax tree, we can conclude that on the first round, it is better for us to stay in the game and risking the 1 over 6 probability of we end the game just by getting 400. And then on the second round, we still risk our game by staying to get to roll the dice and risking 2 over 6 probability to get only 800s. But on the third round, it is not worth it anymore to risk the 50-50 chance to proceed to the next round. So for the third round, it is better for us to quit and go home with 1800 reward. So the answer for our dice problem or die problem to maximize our expected utility or our rewards in this game, you or your AI must stay in round 1 and round 2 but has to quit in round 3. Okay, that's it for the answer of our dice problem using Expectimax. Don't forget to subscribe and thumbs up if you like it. Goodbye.